Today we're going to take a look at some problems from Unit 4 Worksheet 3. We'll look at a pair of them right now. The first one's pretty simple. The second one's a little more challenging. It is really important that you read all parts of the directions before we get rolling to make sure that you do all the parts. In the first part, it says we have a 2 kilogram cart on a frictionless track being pulled by a net force of 3 newtons, and we need to find the acceleration of the cart. So the first thing we want to do is write down the given information. We said that the mass of the cart is 2 kilograms, the net force is 3 newtons, and they want us to find the acceleration. Next up, draw a picture or physical diagram. So we got a cart on a frictionless surface. I have this black arrow to show that it was, that's the force it's being pulled with, and we're defining the system as the cart with the dotted line. Next up, we should draw a force diagram for the cart. We know that force of gravity on the cart by the earth gravity would be pulling down, and the vertical forces are going to be balanced here. This would be force normal on the cart by the track. Remember my vectors here. And then we also have the force to the right, which would be a force of, I'm going to pretend it's a string. So we'll say force of tension on the cart by a string. And that will be our net force. They ask us to calculate and I guess we know that that's a positive. Well, let's say to the right is positive. We'll say up is positive, down is negative. Now, to find the rate of acceleration, we have to consider what we've been given. We have the mass and we have the net force. So to find the acceleration, you probably need to consider Newton's second law. We learned in Newton's second law that acceleration was equal to the net force divided by the mass of the system. In this case, we have the net force is 3 newtons. The mass of the system is 2 kilograms, and 3 divided by 2 is 1.5, and a newton could be rewritten as a kilogram times meter per second squared, and that's over kilograms. Well, what cancels out there? Kilograms cancel out, leaving us with just meters per second squared. So our final answer is the acceleration is 1.5 meters per second squared. And that takes care of all parts of this problem. Problem number 2 is more challenging. It has more working parts. Please consider reading the problem. It says a man pushes a child in a grocery cart with a total mass of the cart and the child is 30 kilograms. The force of friction on the cart is 15 newtons. How hard does the man have to push to get the cart to accelerate at 1.5 meters per second squared? So for this one, we have the mass of the cart and the person, the child is 30 kilograms. The force of friction is 15 newtons. We might need to come back to that in a second. The rate of acceleration is 1.5 meters per second squared, and they want us to find the force of push on the man by the cart. So again, we want to draw a physical diagram. We have a person pushing a kid in the cart, and the system is just the cart and the child. So at this point, we're going to go ahead and maybe say that force of gravity on the cart by the earth is pulling down. We've got force normal on the cart by the surface pushing up. To the left, we have a force of friction on the cart by the surface as well. And because we know the person's accelerating to the right, we know that force to the right has to be bigger than the force to the left. So I just need to make that bigger than the one to the left. And this would be force of push on the cart by the man. The 2 vertical forces are balanced, but the 2 horizontal forces are not. Now, in the given information, they told us the force of friction was 15 newtons. I'm going to make up positive into the right positive, so that force of friction must be negative. So I'm going to have to change in my given information that force of friction is a negative 15 newtons. At this point, is this really about the vertical forces or the horizontal forces? And it's more about the horizontal forces. So if I want to find the force of push on the man by the cart, I'm going to have to know what the sum of those 2 forces are. Fortunately, we were given the mass and the acceleration along the x-axis, so we can calculate the net force. So over here, we can write that the net force is equal to mass times acceleration. We know that the mass of the cart and child together are 30 kilograms. The rate of acceleration is 1.5 meters per second squared. And 30 times 1.5 is 45, and a kilogram times meter per second squared is a newton, which is our net force. Now that we have that, we can find the normal force, the force of push in the cart by the main. So this is the net force only along the x-axis, right? And that would be the force of friction on the cart by the surface plus the force of push on the cart by the main. And which of these have we calculated already? Well, we calculated the net force over here. So that is the net force goes in for 45 newtons over here. We already know that the force of friction was given over here in the given information. So this is negative 15 newtons for our force of friction. And we can use that to find the force of push on the cart by the man. I notice that I'm missing several vectors up here in both the force diagrams and my formulas, so we'll fill those in. And now what do I have to do to both sides to find the force of push? Well, we'll have to get rid of the negative 15 newtons, so we'll add 15 newtons to both sides. In which case, now we have a force of push on the cart by the man equals to 15 plus 45 is 60 newtons. I don't know why it's bright and silly like that for us. I guess my board's a little off. 60 newtons. And that answers that question. All right. In case you can't read whatever that says, 60 newtons. Right. And that's a positive 60 newtons. So that should take care of all parts of that problem. I hope this helps you get started on the other problems. Please keep in mind the questions that I'm asking myself or you guys as we do the problems is the best guide to help this problem answer other questions. I hope that helps.